Hi everyone, I'm Imogen from Course Report. We are a resource for researching which coding bootcamp is right for you. We have a directory of different coding schools, a blog, and interviews with founders, instructors, and students, all to help you work out which bootcamp you want to go to. So today I'm speaking with Lauren Washington, a data science instructor at Thinkful, who's going to tell us all about natural language processing, a concept people often learn about at data science bootcamps and use on the job as data scientists. So Lauren, thank you so much for joining us today.
Thank you for having me.
And so just to give our audience some context, maybe you can start and tell us about your background in data science and your role with Thinkful.
Okay, so I'm more on the statistical side for data science than the software engineering side. I don't have a problem admitting that. But basically my background, I have a bachelor's in economics from Spelman College down in Atlanta, Georgia. And I did some post-bac courses in like Cal 1 through Cal 3, discrete math, statistics, because I knew I wanted to go undergrad school and I didn't necessarily have all the math that I felt comfortable having for stats. And then I went and did a master's in applied statistics at Columbia University. The program is called the Quantitative Methods in the Social Sciences, but basically we just say applied stats, and now people say applied data science. And I've basically worked in a lot of different industries. I worked for the National Opinion Research Center working on the National Immunization Health Survey for the CDC, using cluster analysis to figure out if we were surveying the right people. I worked for Nielsen, basically doing predictive analytics and market research to see who we should serve ads to online. Then I moved out to the Bay Area. Actually, I was in Chicago at that point. I moved to the Bay Area to work for Google, where I basically tried to do anomaly detection to figure out fraud rings inside of the payment system. So I was over Google Wallet and Instant Buy online. And then I actually, at night, I ended up putting myself through my own boot camp. Not my own boot camp, but I went to General Assembly at night to actually learn Python, because I already knew R and I knew SAS and I really wanted to learn Python. And so I just did the part-time program there. And then I became a data scientist and I switched over to a startup in Google's backyard, helping them predict AdWords using machine learning. And now my current job, where I'm the lead data scientist and machine learning engineer for Smart QED, and they're based in the Bay Area. And basically I specialize in natural language processing for them. And I basically predict when IT systems are going to fail, or pretty much recommend the solutions that they need to do whenever their systems do fail, based on looking at forums online, similar to like Stack Exchange, or looking at postmortems and just different things like that. And now I'm actually the lead data science technical expert over the other data science technical experts, and I mentor them at Thinkful to just give a better educator experience for our students.
Wow, you have an amazing background. That's so cool.
Well, thank you.
It makes me feel like privileged to be talking with you.
Oh, thank you. That's very nice of you.
So let's get into these slides now. So maybe next up, you can tell me, what actually is natural language processing?
Okay, so natural language processing, I try to stress to my students that this is basically feature engineering. This isn't a machine learning algorithm. This is how you can take natural text and turn it into something that an algorithm can use. So with data science, typically I try to say that 80% of your job is being like a data janitor and trying to clean things up and trying to turn it into data and features that can actually be worked with machine learning. So natural language processing is a way to process that textual data and turn it into numerical values or categorical values that you can use to actually model text. And I can go a step further and just basically explain that you do basic things like tokenization of text. So let's say that we have this sentence here, natural language processing is a method for, we'll just stop there. If we do an n-gram, it would just have, the first column would be the word natural, the second column would be language, the third one processing. If we did a bigram, it would be natural language, then language processing is, and so forth. And so it's a way you would turn that into something that has a frequency count of how many times those different terms or bigrams or trigrams, chunks of those terms are actually occurring. And then you can do things such as like spam filters for emails, a lot of different things. And you'll say, oh, if we're seeing buy this now, like 3 times in an email or something like that, then you would assume that this is spam and not an important message based on the different pieces of text that we've done a frequency count on.
Wow, that's so fascinating. And then can you give some like real examples of natural language processing so our viewers can kind of understand where they might see it in their day-to-day?
Yeah, so like it says on here, the different virtual assistants that we have at home. I have I won't say the names, but basically because then they'll turn on. But yeah, I have some of my systems here where I speak to them, and then you can think of even one example that usually actually drove me crazy because I use Spotify a lot. One of my things, I'll say, hey, resume Spotify. And then it says, oh, sorry, I can't resume Spotify. And then I'll say, hey, play Spotify. And then it will say, resuming Spotify. But basically, it's chunking up the things that I'm saying into different words to try to basically analyze what I'm asking it to do. And you can ask it to do some pretty random things, but if you put keywords in there that it's going to pick up and throw out the rest, you'll actually find it pretty funny to figure out how natural language processing works. That's a really high level of basically the virtual assistant chatbots. Can use natural language processing to have a database that it's mapping against to say, okay, usually when somebody's asking a question like this is the type of answer that they want. Sort of like a recommendation engine. The spam filters, like I was just talking about, chunking up the different words into different keywords to be able to say, buy this now is more spammy than we have a meeting like later on today. That's more of an important email. So those are just really high level examples. Can also do things like sentiment analysis, like to see the polarity of something, if something is really positive, if something is really negative, if something is neutral that somebody is stating as well. And then you can do things to try to do predictive text as well, which we see on our cell phones every day.
Awesome. That's so cool to think that there's all these things that we're interacting with that are actually doing that.
Yeah.
It's really cool. And then can you tell us a bit about how natural language processing actually works?
Okay, so like I was saying before, you can do feature engineering by doing natural language processing. You can do it by finding tokens in your text. With the example that I was using before, you can do part of speech tagging, entity recognition. So like the president or a state would be able to recognize that. Now, one thing about natural language processing, it takes a lot of creativity if you don't have something very straightforward that it's used to looking at. Like say for my job, I'm looking at code that I'm trying to do natural language processing on. And so we actually have to go and do our own database where we go through the code and we label it and we say, this is context. So in the future, remember that this is context. And it's not actually built in to the models that are already provided through like Python or R or SAS. But pretty much you're just going to pre-process that text. If you're doing something like a normal supervised learning model, say classification of important messages versus spam, then you would already have a chunk of emails that you've already seen in the past that are important messages and a chunk of emails that are spam messages. And then basically you'll see the words that are associated with important messages and spam messages so that a new one can come in and you can basically find the similarity between those. And a huge thing that you use with natural language processing is basically calculating the similarity between different words and different documents. And you can do a lot of different recommendations based on that. And so basically you can take a supervised learning model where you already have something that's defined like important and spam, and that's pretty straightforward to say this is what we're trying to classify. Or you can do something unsupervised and do something like topic modeling, And it would be really cool to take something like a textbook where you already know what the topics are pretty much modeled as because you see a table of contents already. And then you can basically do topic modeling on that. And then when you see the results, you'll usually see that it's pretty much putting them in the same topics that you already see in the table of contents because of so many similar words in those particular documents. So usually you take a corpus, which is basically every document that's contained in whatever you want to analyze, and then you try to find the similarities between different subjects in that. I had one student who actually did a project on Hillary Clinton's emails, and it was actually really interesting to see the clusters that came back on that. You saw some that were probably like 3-word emails, like, okay, chat about this later. That's like 4 words, but still. Or then you'll see something that actually said, this cluster is about Benghazi or something like that. And so it was actually able to do that level of sophistication of like modeling different topics. So that's unsupervised versus supervised, where you're saying this is what we're actually looking for. You can also get a little bit deeper. I'm sure people would want to just do supervised and unsupervised right now, but you could also get a little bit deeper in the future and use something like a neural network, do like recurrent neural networks to be able to do predictive text, do convolutional neural networks to be able to figure out the context of what you're talking about. So yeah, there are a lot of different things. And basically, as long as you already know how to do supervised or unsupervised learning, it should be pretty straightforward after you know how to figure out how to do the processing and feature engineering of the text.
Wow, thanks for that. That was a great explanation. And then what actual technologies or programming languages are used to build these natural language processing pipelines?
Yeah, so I'm most familiar with Python and R because those are the languages that I program in currently. But with Python, there are a few different things that you can use. Some of them are on here. You can use like Natural Language Toolkit. That pretty much has a lot of different things that you need. You can do your tokenization there. You can do part of speech tagging. It's pretty much everything that I've already mentioned. Beautiful Soup is great as well. You can also use that to summarize text, which is pretty good for like news articles, or maybe if you want to do a brief summarization of like your bibliography on something, then that's pretty helpful as well. And then Spacey and Ginsum, those are things that are also available in Python, and they do all the same stuff. There are a lot of different modules that you can use to do similar things. In R, there's definitely OpenNLP, there's R text tools, there's tokenizers, which I'm sure you can figure out what you do with that. QDAP is actually quantitative discourse analysis. So that's a pretty helpful module or library that you can use as well. Neural networks, basically technology for that. You can use Keras, TensorFlow to be able to do the things like the recurrent neural networks and convolutional neural networks that I was talking about as well.
That's awesome. And then can you give us some examples of some of the companies which actually use natural language processing?
So Google, definitely for their search engine. And I think it's really funny once you start going through natural language processing, you'll get a lot more efficient at Googling things because you'll start thinking about the keywords that are most important that an algorithm would take in order to get you the best results. So definitely for that. For Facebook, you can think about all the bots that they have now, the chat bots that they have. If you forgot something in your cart, or if you have some type of question to ask a business, they basically have a bot that will immediately come back and talk to you. Yeah, there's definitely a lot of different situations that you can use NLP in, even for customer service at other companies. Whenever there's a customer service ticket, you can prioritize it by sentiment. Does this person sound really negative? Do they sound happy? Are they using positive keywords, negative keywords? Yeah, basically you can do a summarization of their tickets. It's just really helpful in all contexts because I believe most companies have free text data. A lot of them just don't necessarily know what to do with it yet. But some of the high level things that you can think of that you use every day are search engines and chatbots for sure.
That's really cool. Yeah, those chatbots used to be such a mystery to me. I was like, how do they know what to say? But that makes sense now. And then why is natural language processing something that could be good for beginner data scientists to learn?
Yeah, so why learn natural language processing? I've noticed that a lot of companies are actually looking for this skill set now. Um, a lot of people have a lot of textual data that they have probably had humans just read through prior to try to gauge what's going on. And now we can do it in a more efficient way with people that know how to do natural language processing, whether it's for automating a queue and putting the most egregious cases at the top of a queue for customer service, or if it's just trying to analyze the people and whether or not they like the products that you're giving. There are a ton of different websites that use recommendation engines. Once you start learning more about natural language processing and machine learning, it will be really funny to go to different websites and think like, oh, they probably just have this one algorithm underneath that's like looking at what I'm typing, and that's why this website is so great and able to recommend these things to me. So it's definitely a new skill set that's in demand, but it does require a lot of creativity because there are a lot of modules that are built on plain text that we're used to seeing. But you have to be able to build on top of that and build it out for your particular use case and be familiar with your business domain and maybe different acronyms that are used that need to be built into the dictionary, and maybe something that seems really negative in regular text is actually something that's possibly positive in your business context. So I think if you really like creativity and something that's constantly changing, something that definitely requires a lot of white papers still. And so you could get yourself out there in the industry if you go into natural language processing. This is definitely a great skill set to have.
That's awesome. That's really fascinating. Thanks for explaining all of that. And then maybe you can tell us a bit about, like, if people are wanting to learn natural language processing, where should they start?
Okay, so definitely just understanding machine learning first, so supervised learning and unsupervised learning, because like I was saying, you're just doing feature engineering on text, and then you have to feed them into these models, the supervised and unsupervised models. Understanding distance metrics, just because I was saying that there's a lot of similarity calculations to say, oh, this batch of text is very similar to this batch of text over here. So just understanding the basics of that. You don't have to go really deep into the math, but know what a similarity metric is. Reading blogs and reading books. I actually have a book sitting right here. Like this natural language processing book is really key for using. So just like natural language processing with Python. It's the O'Reilly publisher, one of the like most popular publishers that you can have in tech. There's also a great PDF out there that one of my students found, and then I saw it and I bought it too. It's called NLP for Hackers. I love the website towardsdatascience.com. I always send those websites to my mentees as well. They just have a ton of tutorials on natural language processing, and they have really great feature engineering tutorials that just get straight to the point on like, this is how you can do topic modeling, this is how you can find similarity, this is how you can do tokenization. And then just go and start researching on Kaggle and look for places where people have done natural language processing, because on Kaggle, you can always download data to play with it yourself. You can look at people's kernels. And when you look at people's kernels, you can see the code that they've already done on that data set. And that helps you learn and see, okay, these are the different tactics and methods that people are using for this. Also, if you're an R programmer, I think R pubs is great because people are basically publishing their different notebooks and their code that they've done for different projects as well.
That's awesome. Thanks for that. And then how is natural language processing covered in the Thinkful curriculum?
Okay, so I say that you have 3 or 4 different ways of being exposed to natural language processing in the curriculum. First, when you get introduced to naive Bayes classification, we do something about like positive or negative reviews and being able to say like, okay, these words define something that's positive or these words define something that's negative, and being able to classify that for like Amazon, IMDb, and different websites like that. Then unsupervised learning, we start really getting into the deep depths of natural language processing. I would say naive Bayes in that chapter, it's a little more brute force because it's probably the first chapter that we have in supervised learning. And so we're not diving straight into everything that you do for NLP. But once you get into unsupervised learning, you're really just like thrown into that. And you're like, okay, this is how you do tokenization. This is how you figure out TF-IDF, which is like term frequency, inverse document frequency, which you'll hear a lot about, basically showing the importance of a term showing up in an entire corpus just based on the frequency divided by the number of documents. And you'll learn how to do different things with Spacey, one of the modules that I've discussed. You'll see a guided example of how to actually do like the processing of text and implement it in an unsupervised learning model as well. Then we also have a mandatory capstone where you have to have at least 10 different authors, and you need to be able to classify which author belongs to which block of text. I've had people in the past who have actually taken like song lyrics and been able to predict the artist that was attached to the song lyric. I thought that was pretty cool. And then you also have an NLP specialization. So if you even want to go even deeper, you can choose to specialize in that. And we have different specializations. We have network analysis, big data, NLP, time series, just like a ton of different specializations. But no matter what, you're going to be exposed to NLP, but then you can also choose to specialize in it later.
That's awesome. That's so cool that there's all those different opportunities at Thinkful. Lauren, you already talked about some great resources for learning natural language processing. So here they are on the screen. If anyone wants those, they're here. And we'll also link to those in the accompanying blog post. So Lauren, I think we've got through all of our slides now. So maybe, is there anything else you wanted to add about, natural language processing, or, anything fun about it that people might be interested in hearing about?
I would just say, don't be scared to enter into it. When I was at my first data science job, I wasn't tasked to work on natural language processing. I was actually doing a lot of experimentation, A/B testing, and I knew that I wanted to get into it. And so I started my own side projects, and I started going to marketing teams and like, I can analyze your headlines and things like that. And so I would just say, explore it. Don't just say, like, if you go through it one time, you think that it's a little bit difficult. I would say just keep working at it. Make sure to look at different resources online where people are actually showing you how they worked through it before. And yeah, just remember, it's just a way of doing feature engineering. If you know how to do machine learning, you can pick up natural language processing. So please don't be discouraged.
Oh, that's such great advice. Thanks so much for that. Well, Lauren, thank you so much for joining us. This has been a really great chat, and I think it's going to be a really interesting piece for people to watch.
Thank you for having me.